Chapter 7, section 7.3 and 7.4. 7.3, inverse of square matrix. If you have a number like 5 examples, and you multiply that by 5 to the power of -1, which is inverse of this number, the outcome is always 1. The same idea be used for matrix. If you take a matrix and multiply that by inverse of that, then matrix times inverse of that matrix, the outcome is always matrix of 1, which matrix of 1 in case of 2 by 2 is like this. 2 entries are 1 and 2 are 0. So if you want to prove that two matrices are inverse of each other, then when you multiply these two, the outcome always has to be 1. So for example, show that this matrix of B and A are inverse. So in that case, you get a proof that when you take matrix of A multiplied by B or B multiplied by A, in either case, you end up having a matrix of 1. That's how to prove that these two matrices are inverse of each other. So if a matrix has inverse, A has inverse, then A is invertible or non-singular. Otherwise, A is singular. A non-square matrix cannot have the inverse. So if you want to have an inverse, you must have a square matrix. And for example, if I take, you understand that if you take a matrix and multiply that by inverse of it, the outcome is always 1, right? So if you already have your matrix, but the inverse is unknown, how do I find the inverse or just X? X means this is unknown. So in that case, you take your original matrix, which is this, multiply that by X, which are these 4 variables, and the outcome is 1. So we got to solve this. So when you multiply these two, you end up having a matrix with all these letters. And now each entry, like this entry is equal to 1, this one is equal to 0, and this one equal to 1. So you end up having two equation, two variable system. You could solve it and find all your entries. So that's one way to find the inverse. Okay, by using this method. The other way to find your inverse is, so you understand that if you take, one thing we noticed that when on that example, the previous example, the matrix of A and A to the power of -1 or matrix and its inverse, they all have the same entry. See 1, 4, -1, -3, this also has the same thing, okay? And so this should be positive. So in that case, the only difference is they all are kind of opposite of that. So if this one is A is that 1, 4, -1, -3, -1 is -3, -4, 1, and 1. So they all have an opposite sign of that. So to find another way to find this matrix is if you take A, which is the original matrix, multiplied by identity matrix, if you could change that in a way that your identity matrix move to first, and then the second matrix would be your inverse. So what I do is, like, I have this matrix, okay? I multiply that by matrix of 1. We do all these multiplications. At the end, this matrix of 1 would be first, and then the second one would be your inverse. So basically, A times I, if you change it to I times a matrix, this matrix is your inverse. That's what they show it here. So that's the second method, and we could also apply that for 3 by 3. See, this is also another square matrix, 3 row and 3 column, 3 by 3 matrix. To find the inverse, somehow you got to take that, multiply by identity 1 or matrix of 1, And you do all this calculation. At the end, this matrix of ones, you should switch here. And what you have after the second matrix is your inverse. Another method is to find the 2x2 matrix is using the formula. This is the easy one because you already have all the formula. All you need to do is switch all the letters and the numbers. Like if you have a matrix of A, which is entry of A, B, C, D, you could, to find the inverse, you just take these letters, whatever numbers are, and you put in this formula. That's probably an easy one to do, okay? So like for this one, they show you for these, look at these examples. Denominator is AD minus BC. Denominator is A times D minus B times C, which is a determinant. We discussed this on the next page. So determinant of the matrix would be the denominator. Okay, you put that number, and then would be 1/4. And then you put all these D minus B, the opposite of what you have here. See, if this is A, you put A here, you have B, you put minus B here. Get C, you put minus C, so on. So it's strictly it's just using the formula to find the 2x2 matrix. So if you have a formula available, you just take all those entry and input into that one. This is when you solve the system using the inverse matrix. You understand that, like in these equations, A times X equal to B. To find the X, you need to divide both sides by this A, or X is, you kind of break this into 1/A times B, or inverse times B, okay? So that means, first, this is your original equation. You take all the coefficients, and that would be your A. There are three variables here, X, Y, Z. You put those here. This is basically your unknown. What you have on the other sides is your B. So AX times B is this, and you have to somehow work on this and change it to your variables is inverse of that matrix times B, which you have here. So if this is your A, you find the inverse of that first, and then you put it into this calculation. You know, there are ways of using your calculator and find a 3x3 or 2x2 matrix. And there are some good videos on YouTube that you could watch and show you how to use the calculator to find the numbers. And this is basically for you to verify if your final numbers are correct or not. And then on section 7.4, we talk about the determinant. What is determinant? Every square matrix can be associated with a real number called determinant, and has many uses, and several will be discussed here. So if you have a 2x2 matrix, how do you find the determinant? Determinant is you multiply these two entry minus this two. That's how to find the determinant. So determinant of 2x2 matrix is A1, B2 minus B1, A2. And this is how the symbol, we use two vertical line around the matrix. That is indication of determinant of the matrix. So these examples, like how do you find the determinant of this 2x2? You multiply these two minus, and then this. So be careful about the second part because that's a negative. Sometimes if you don't put it in the parentheses, you may mix up the numbers. Here, I'll kind of show you how to input the numbers into your calculator if you want to find a matrix, you know, and the calculator does have that. So always put the numbers in the calculators and we'll do it for you. And then The last one is, they call it minors and cofactors. Minors and cofactors, how do you find that, and what are they? To define determinant of the square matrix of 3 by 3. It is helpful to introduce concept of minors and cofactors. There are two letters involved. One is the C, C-I-J, and the other one is M. And when you go through the example, you understand that better. First, we want to practice how to find the minors and cofactor of this 3 by 3. Okay. So in that case, what does M11 means? M11 means this is the first number is always I, or the row, and the second is a column. Means you take the first row and the first column. If you delete this, what is left? This. Find the determinant of that. That's your M11. How do you find M12? M12 is the first row and the second column. If you remove these, what is left is 3, 2, 4, 1. You find the determinant of that. That is M12. Okay, so this is just for these two, and then you could basically calculate the rest. So you find all M1, 1, 1, 2, 1, 3, 1, so on. Then you have to find C11, C1. C11, again, according to this formula, which I put it here. So C determine whether your number is the plus or minus. Like if I want to calculate sine of C21, 2 and 1 both are, 1 is even, 1 is odd. So 2 plus 1 is odd numbers, and negative 1 to power of odd is always negative. And M21 is 2, so that would be your C. That's how to find the C. C again is your sign. It help us to find the sign. That's how to find the minor and cofactor. So what is C22? C22, again here, it's -1 to power of even number, okay, and M22. So this part is positive. -1 to power of even number is always positive. So all it is just M22, which you already calculate, is -4. See, so C22 is -4. And that's the reason. So Cij is -1 to power of I plus j times Mij. Mij, I is the rows and this is columns. So this is your formula. So you find all the m's first, and then whether I and j, when you add, is positive, is odd or even, that would determine the sign of your numbers here. Now, where do we use that? To find the determinant. Like if you want to find a determinant, this is a formula, A1, C1, A1. It depends. Like for this one, for 3 by 3 matrix, okay, you are using 3 of those, 1, 2, 3. So it would be A1, C1, A1, 2, C1, 2, A1, 3. And here, it doesn't matter what row or what column you use. You just use one of them. For instance, if I want to find a matrix, the determinant of 3 by 3, I'll just go ahead and pick one that has, see, row number 2, like this one. And you find this C11, C12, C13, and then you put them here. I'll show you here. That's how you came up with that. So this row, if you pick this, all you need to do is find your C21, C22, C23. Okay, so these are your letter of the A. You know how you have A11, A12? These are, if you pick this line, that would be your A value that you put here. And then C, we determine the C. And we show you how to find the C ones. So here, and now if you have, and I show you, I have the complete calculation here for you to see, okay, for that examples, for the different examples, I'm sorry. For this one, I'll show you the complete calculation, how to find determinant of 3 by 3 matrix, okay? So what I did, I took a first row. You could take any row if you want, or even any column. So I took this one. The first row is 3, 4, -2. 3, 4, -2. And then all I need to do is find these three that I show you here. C11, C12, C13, and then you put it back here. How do I find C11? That's how to do it. How do I find M11? So on. And then at the end, it shows you the same thing for 4 by 4. Remember, because you have 4 by 4, when you pick a line, that line has 4 entry in it. So to find a determinant, you find a, like if I want to use this column, it's easier to use. See, it could be any row or any column. Like here, I think I picked these columns. So in that case, it helped me because a lot of numbers are 0 here. So that, and then in the document that you see online for the lecture notes, you have the solution for all the problems.